Introduction. It appeared as a ghost on radar, a fleeting shadow moving faster than a rifle bullet. It outran every missile fired at it. It flew on the very edge of space, its pilots wearing suits designed for astronauts. This is not science fiction. This is the story of the fastest air-breathing aircraft ever built, a machine that became a legend, the SR-71 Blackbird. Chapter 1. The Cold War's Imperative. The story begins in the tense atmosphere of the Cold War. The United States needed to know what was happening deep inside Soviet territory. The U-2 spy plane was their eye in the sky, but in 1960, one was shot down, and the illusion of invincibility was shattered. A new kind of spy plane was needed, one that couldn't be touched, couldn't be caught. The task fell to Lockheed's legendary Advanced Development Programs, better known as the Skunk Works, and its genius leader, Kelly Johnson. The challenge was monumental: build an aircraft that could fly above 85,000 feet at more than 3 times the speed of sound. Chapter 2. Forging the Impossible. To build the Blackbird, engineers had to invent new technologies from scratch. At Mach 3.3, air friction would heat the aircraft's skin to over 500 degrees Celsius, hot enough to melt conventional aluminum. The solution? A new alloy, 93% titanium, sourced secretly from the Soviet Union, the very country it was designed to spy on. This metal was incredibly difficult to work with, shattering tools and requiring new manufacturing techniques. The plane was built with loose-fitting panels that would expand and seal in the intense heat of high-speed flight. On the ground, the Blackbird constantly leaked its specialized JP-7 fuel, a liquid with a flashpoint so high you could drop a lit match into it without effect. It only truly came alive in its element, the searing heat of the upper atmosphere. Chapter 3. The Heart of the Beast. Powering this Titan were 2 of the most extraordinary engines ever created, the Pratt & Whitney J58s. These were not simple jet engines, they were a revolutionary hybrid. At lower speeds, they functioned as afterburning turbojets. But as the Blackbird accelerated, massive movable cones at the front of the engines moved backward, and a complex system of bypass doors redirected airflow, transforming the engines into highly efficient ramjets. This turbo-ramjet design was a masterpiece of engineering, allowing the SR-71 to breathe the thin air at the edge of space and propel it to speeds that remain classified to this day. Chapter 4. Life on the Edge of Space. Flying the SR-71 was unlike any other piloting experience. The 2-man crew, a pilot and a reconnaissance systems officer, was sealed in fully pressurized astronaut suits. A single tear in a suit at altitude would mean instant death. Missions were grueling, lasting for hours, requiring mid-air refueling from specially designed tankers. The view from their cockpit was of the curvature of the Earth and the blackness of space above. Their primary defense against the thousands of missiles fired at them over the years was breathtakingly simple. They just pushed the throttle forward and accelerated, leaving the threat far behind. Chapter 5. The Legend and the Legacy. For more than 2 decades, the SR-71 flew with impunity, gathering critical intelligence from the world's most dangerous hotspots without ever suffering a single loss to enemy fire. Its operational costs were immense, and with the rise of advanced spy satellites, the program was eventually retired in the 1990s. Yet its legend only grew. The SR-71 was more than an aircraft. It was a symbol of human ingenuity, a mechanical titan that conquered speed and ruled the skies, a machine that defied its enemies without ever firing a shot. Conclusion. The Blackbirds now sit silently in museums, but their story continues to inspire. They remind us that with enough courage and brilliance, the boundaries of what is possible can always be pushed further. Subscribe to ReelWisdomHub for more legends of engineering.